All right, let's talk about something every developer goes through. We're going to go on a journey from a single, simple idea all the way to a full-blown production-ready application. We're taking it from the first line of code to the finish line.
So here's the big question, right? How do you actually bridge that massive gap? I mean, you've got your code, a database, all these other dependencies. How do you get all those moving parts to play nice together and then package it all up so it can run like reliably anywhere in the world? Well, stick around because that's exactly what we're going to break down today.
Okay, to make this whole thing concrete, we're going to follow a real project. We're building a core banking API. And hey, don't worry, we're not actually starting a bank. This is just a technical exercise, a way for us to really dig into the modern workflow for building and shipping software. And our journey, it all starts right there, on the developer's machine.
All right. Section 1, orchestrating development. So before you even dream about deploying to the cloud, everything, and I mean everything, has to work perfectly on your local machine. But modern apps, they're complex, right? You've got your API, a database, maybe a couple other services. How in the world do you get them all talking to each other without completely pulling your hair out?
Well, this is where a tool like .NET Aspire just shines. The best way to think about it, it's like an orchestra conductor for your project. See, your app isn't just one instrument, it's a whole symphony of different services. And Aspire's job is to stand at the front and make sure every single part plays together in perfect harmony while you're developing.
So let's break down this little orchestra of ours, shall we? The API, well, that's our lead singer. It's the absolute star of the show. Then you've got the PostgreSQL database, which is like the rhythm section, laying down that steady, reliable backbeat of data. We've also got a migration service, and that's our stage crew, you know? They're the ones making sure the database structure is set up perfectly before the show can even start. And Aspire's dashboard? That's the conductor's stand. It gives you that one single place to see everything that's happening.
And here's the really crucial part. Instead of you having to manually wire all these pieces together and, fiddling with those nightmare connection strings and trying to remember which service to start in what order, Aspire just handles it automatically. This is a huge win for developers. It gets rid of a massive source of headaches and errors, and it lets you focus on what you actually want to do, build cool features.
Okay, Section 2, bringing the API to life. So we've got our local development environment all beautifully orchestrated. Now it's time for the fun part, actually building the thing. We've got to implement the core logic that makes our banking API, actually work.
For this project, we're really zeroing in on 3 core things. First, we need to be able to create and manage customer profiles. Second, we got to be able to open new accounts linked to those customers. And third, and this is the big one, we have to handle transactions. Deposits, withdrawals, transfers, this is the real heart of the application, right here.
And here it is, the classic developer phrase. You've heard it a million times, maybe you've even said it, but it works on my machine. And you know what? That's just not good enough. We've written the API code, sure, but that API needs to talk to the database. So how do we guarantee that the entire system works together, flawlessly, from end to end?
The answer? Integration testing. Now, this is different from unit tests, which just check these tiny little pieces of code all by themselves. No, integration tests are about making sure all the different parts actually work together. We spin up the real API, connect it to the real database, and run automated tests that act like a real user, creating a customer, depositing money, the whole shebang. This is how we prove our entire orchestra is playing in perfect harmony.
All right, Section 3, from code to containers. So, let's recap. Our code works. Our tests are all passing. We are feeling good, confident that the system is totally solid on our local machine. But now we face the next great challenge. How do we package this thing up so it can run reliably on any server, anywhere in the world?
This really gets to the heart of the matter. The old way, man, that involved manually setting up a server, installing all the right software, and basically just praying that the production environment somehow matched your development one. It was brittle, it was a recipe for disaster. The new way is all about packaging our application into a single, standardized unit that has everything it needs to run, all baked right in.
And that standardized unit, we call it a container. The best analogy really is a shipping container. Think about it. It doesn't matter if it's full of bananas or car parts. The container itself has a standard shape and can be moved by any crane on any ship, anywhere. It's the same for software. Our API, packaged up in a container with a tool like Docker, can run on any machine that speaks container.
And just like that, the whole works on my machine problem, it's solved for good.
Okay, moving on to Section 4, Deploying with Docker Compose. So we've got our application nicely packaged in a container. That's great. But wait, our app isn't just one container, is it? It's a whole collection of them. We need the API, the database, maybe some other services. So how do we define and manage this entire fleet of containers when it's time to deploy?
So this is what our final production setup is going to look like. First, for scalability, we're actually running 2 instances of our API. In front of them, we've got something called a reverse proxy. You can just think of it as a traffic cop, directing incoming requests to one API or the other. Of course, we still have our database and our trusty migration service. And the magic tool that lets us define this entire stack in one simple file, that's Docker Compose.
Now, the absolutely critical thing here is the startup order. I mean, think about it. You can't start the API if the database isn't even running yet, right? Docker Compose is brilliant because it lets us define these dependencies. So as you can see, step 1, the database has to start up and get healthy. Step 2, the migration service connects and gets all the tables ready. Step 3, only then do our 2 API instances fire up. And finally, step 4, the proxy starts, ready to route traffic. That controlled sequence is what makes for a stable, reliable deployment.
Okay, let's take a step back and look at the big picture. The entire workflow we just walked through. This really is the complete modern journey of a .NET application, all the way from a basic concept to running in the cloud.
And this timeline just lays it all out perfectly. First, we orchestrate our local setup with Aspire to make life easy. Then, we implement the actual features. After that, we verify that the whole system works with integration tests. Then comes the packaging. We containerize each service into a portable Docker image. And finally, the grand finale. We define and deploy the entire application stack with Docker Compose. See how it all fits together? And at the end of the day, this is what it's all about. We are moving away from those old, scary, manual deployment steps that are just begging for human error. This entire workflow is designed to be one thing, a reliable, repeatable, and scalable process that you can trust every single time you ship new code.
So there you have it. We went from a local development orchestra conducted by .NET Aspire all the way to a fleet of containers deployed with Docker Compose. This right here, this is the blueprint for building and shipping modern applications today. So the only question left is, what are you going to build with it?